won't put the live stream on.
Okay. So we'll go ahead and get started. Welcome back. And as the day progresses, help yourself to the food back there. We don't want to take it home. So we'll jump in here in a minute with about herring, about fish. Again, we want to thank the many people that have helped us out. One other announcement is after we're done today, we're going to have a social hour over at the Whittier Inn. So if you want to join us for that, feel free. It's you're on your own for your drinks, but we'll be over there recapping things and talking about what fun things we're doing this summer, I'm sure. Again, we want to thank the Titilla Corporation for their support of this event, the Prince William Sound Regional Citizen Advisory Council for their support of youth and getting youth involved in this event and educating youth, and the City of Whittier for providing this facility and also helping out with funding us. Also, we want to thank the other Chugach level, more of them, Stan Stevens Wildlife Cruises, Discovery Voyages, Glacier Jet Ski Adventures, and Phillips Cruise and Tours, and many others. So next up, we have Alysha Cypher is going to talk about herring patterns in Prince William Sound. Alysha is a postdoc researcher, has studied fish heart physiology, herring migration, and the crude oil effects on young herring, which has been on our minds here in Prince William Sound since at least 1989, an oil spill. And she is also, this is interesting, a naturalist while chasing frogs. One thing I love to do is chase frogs. So Alysha, is Alysha here? Yes, there you are. Great.
Hi, everybody. I assume slides are going to come up. Okay. Hi. So yeah, I've been at the Prince William Sound Science Center since mid 2020. And yeah, but prior to working at the Science Center, I was at the Northwest Fisheries Science Center in Seattle. So today I'm going to tell you about herring patterns in Prince William Sound, but I'm also going to tell you about some of the oil work that I did with NOAA Fisheries in Seattle, and then put that in the context of what I've learned since I've been in Prince William Sound and have more experience with the population and worked with the Herring Research and Monitoring Program, Gulf Watch Alaska, and Fish and Game. So as many of you know, I'm sure, the herring life cycle, we'll say it starts with demersal eggs. So they're clusters of sticky eggs that the herring deposit along shorelines onto vegetation. And then they'll hatch after like 10, 20 days, depending on temperature, into this larval stage. And the larval stage is totally at the mercy of currents. So they just go wherever the currents push them. On a good year, you'd hope that they would get sucked into bays. And then in a bad year, they may get, in a circle in the middle of the sound where they're probably not going to survive. And then after about 2 months, they metamorphose, and that's when the scales become visible. And they're a lot more adept at avoiding predation, things like that. And then they will experience their first winter. So they need fat reserves prior to their first winter, because that can be a high mortality time for them. And then after that, the next 2-3 years, they will still spend a lot of time in the bays. We think the same bays that the larvae get sucked into. So they tend to stay in the same location, we think. And then they reach adulthood where they can have sex. Yay. And then the process starts all over, where you'll see spawning. So, and then this is probably impossible to see, but I have a map in the upper left corner that shows it's a cumulative historical showing you, do that. Showing you where herring have historically spawned cumulatively since the 80s. So you can see that it's, a fair proportion of the coastlines that are in Prince William Sound. But then you all know what happened. The Exxon Valdez oil spill. So it occurred in March of '89. tanker hit Bly Reef, and then some wind and storm activity over the following days to weeks pushed the oil to the southwest out Montague Strait. And this happened at the same time and shorelines, coated the same shorelines that herring were using for spawning. Some major and some minor areas were coated with oil that herring used to spawn. And at the time, there was some like research or observations happening right after the oil spill to try to figure out what the hell's going on. So they went out and they did observe some oil coating like on herring eggs. There was some observations of some toxicity to larvae, some evidence of that. And then in the years after the spill, they did find adult herring that, appeared to be diseased. So evidence of disease, but all kind of maybe not enough data to really like definitively say anything, because everybody was in a rush at the time to clean up the oil. But then 4 years later, the collapse happened. So 1993 was the herring collapse, where we went from 140,000 tons to 20, and we've remained there ever since. And when I'm walking around Cordova and people meet me and hear what I'm doing, and they ask me like, that herring collapse, was it the oil? Well, that's what I was working on at NOAA Fisheries and have thought a lot about since. So when I worked at the Northwest Fisheries Science Center, the group that I worked with has done tons of oil exposures on various marine species, and specifically the early life stages, because that's when they're really sensitive to oil. If you expose adult fish to crude oil, they're just kind of like, whatever. But the embryos and the larvae, it can have severe effects. And that was well known before I showed up in Seattle. And when we would do high concentration exposures, we'd often see this very ugly, bulldog or Darth Vader like malformations. And I think that that's what they're referred to in the manuscript. I couldn't find it on the fly before this to prove that, but I'm pretty sure that's the phenotype described in the manuscript. And when I say high concentrations, I mean like higher than environmentally relevant, but if you or I took a glass of that water and drank it, we probably couldn't taste the oil in it. It's still very low concentrations. So we see like these facial malformations, this like curvature of the spine, some really ugly looking fish that just don't live. But while I was with NOAA, we did some very low concentration experiments that were environmentally relevant. It felt like we were putting the tiniest drop of oil in like a lot of water. And we didn't see the severe malformations that we did with the higher concentrations. They appeared fairly normal. But then we looked at their heart morphology. And one of the most common indicators of whether or not a baby fish is exposed to oil is if they have an edema around their hearts, of fluid accumulation. But while I was with NOAA, we identified a more sensitive variable. Hopefully I can play this. I broke it. Well, anyway, we, oh. Do I still have an echo? Oh, good. I don't want to hear my own voice. You guys can listen to it. There might be, but it is not necessary. I broke it. So we take these videos of herring embryos and larvae. This one's taken with my cell phone, so it's actually not that great. And maybe you can't see what I was hoping you'd see, but fish have an atrium and a ventricle, so they have two chambered hearts, whereas we have two atrium, two ventricle. And as the ventricle develops, like in the end, you end up with a very pyramid-shaped heart once they reach metamorphosis. But early in development, it's kind of like shaped like an oval, and then it elongates into this very clown boot kind of shape. And that's all the natural part of the development of the heart. But we found that when we, you can resume it back on the next slide if you want. We found that when we exposed herring embryos to oil, that elongation of the ventricle didn't occur. And it turns out that that's very like biologically relevant, and that really, is not good for the fish. That part of development doesn't happen. But if we stop exposing them to oil, like environmentally relevant, like the oil spill just stops and everything's clear. They do catch up. So we stop the exposure, and then the hearts will catch up, and then later in development on the larval, we'll see that their hearts look very similar. It's like, oh, maybe they're fine now. But then when we these same fish, we grew them out to juvenile stages, and then we did an array of tests on them, and we found that they aren't really caught up. So we see that they don't grow as well. They're smaller at the same time. So you don't have to like really look at these figures, but I'm just kind of showing you that there's an array of research that's like showing that the juvenile stage, there's something off. They don't swim as well. So their swim performance, that means that they kind of like crap out earlier when they're trying to swim fast. So a valuable thing when you're trying to escape a predator is to be able to swim fast. Their maximum metabolic rate is lower, which is related to the swim performance. You need to be able to up your metabolic rate and get moving. And then the wall around their heart is thinner. So the myocardium and the cells within the myocardium are more spaced out. And I didn't include any more figures on this, but that definitely, we have evidence that affects the efficiency of the heart as a pump to push blood through the body. And that's all really important. And this ultimately leads to fewer fish being alive later. So delayed mortality. We don't, when you count them at the end, there's fewer of the ones that were exposed to oil in the beginning. And then one experiment I did was an overwinter fasting. And so we took those oil exposed embryos, grew them up, and then we put them in tanks and didn't feed them for like months. And they starved like 12 days sooner than the unoiled fish, which is significant when you're in the wild and there's no food, but you need to eat. So the moral of the story is that we get a fish that has a very cardiovascular disease-like state. And just to remind you, this was the 1989 year class that was exposed to oil when they were eggs, right? So that's the sensitive stage. They were the ones in the water. And even though they may have grown up to have this cardiovascular disease-like state, the loss of the 89 year class is not what caused the collapse. So if we go back to the collapse, in 1993, the 89 year class would have been 4 years old. But in order to understand how the collapse happened, we have to look at recruitment. Not why it happened. We still don't, spoiler alert, we still don't really understand why. There's tons of ideas out there. I'm sure you have your own ideas if you thought about this much. But to understand how it happened, you have to look at recruitment. So this is a figure over the same time scale, year class, the years since the 80s prior to the collapse. And this figure doesn't really show the collapse. So I put a red line in there that shows about when the collapse happened. And it shows very strong recruitment. So the 88 year class, you can see there, that's, so recruitment, when I say recruitment, I mean, that's the number of fish that are joining the spawning population in a year. It's not the biomass, it's the number of age 3 fish joining the spawning population. And in herring, what drives recruitment is strong year classes. So these are years that dominate the spawning population, and they have very high recruitment. And so the 88 year class was the high recruitment, strong year class at the time. And they spawned in 92. They were 4-year-olds then. And in 93, they didn't show up. And that's the main contributor to the collapse, is that the main year class that was contributing to the biomass and to the mild days of milk didn't show up when we expected it to. And the hypotheses behind that include, a major disease event, which can cause that kind of mortality. Reduced food supply. So in the late 80s, when there was really high herring biomass, that in itself was an anomaly that the herring were getting that high. Like, it was awesome, but it was an anomaly in itself. And so there could have been a loss of food supply that led to that. Lingering oil remains a hypothesis, although less likely. High predation and fishery takes are, all could have contributed together or We may never know. But just to like give you an idea of what I mean when a herring class dominates, is this figure is showing you each year, doesn't show you how many fish are in the water. It shows you the proportion by age class. So the proportion of that year, the herring in the water, what percentage are 1, 2, 3, 4 years old. And if we look at the strong year classes, 84, 88, 99, and 2004 for Prince William Sound, you can see that they have big bubbles. That means that they make up most of the herring population for their life, up until 8, 9 years old in some cases. They dominate the proportion of the herring population. They're making up most of the biomass, and they're doing the spawning. So what drives these strong recruitment years? We still don't really know. Spoiler alert. But this is just a list of the strong year classes in Sitka and Prince William Sound. And there's two main patterns that emerge just by looking at these years. The first one that sticks out is that 76, 80, 84, 88, they're 4 years apart. And so funnily enough, the main predictor, the highest predictor of whether or not a strong year class for herring will occur is leap year. They love leap years. So strong year classes almost exclusively occur on leap years. They really like that extra day or something. That's not my joke. I stole that. But the only anomaly in this list is 1999 for a leap year. And then if you look at just comparing the rows with Sitka and Prince William Sound, you can see that they occur on the same year. Sitka's pretty far away. So this indicates that there's regional synchrony. The strong year classes are occurring in Sitka and Prince William Sound in the same year. And that's probably not local factors, like local things that are driving those strong year classes. It's something on a bigger scale. And then the leap year pattern also kind of indicates that the herring life cycle may affect these strong years. In that, if you're in the strong year class and you're dominating the population as a larval stage, you may be competing with your own younger peers. The next year, you may be like, nah, we're taking over. And so you're competing, the year classes may compete with each other to maintain this 4-year pattern. But then, we haven't had a strong year class for Sitka between 2000, 2012, and then 2004, 2016 for us. It resumed on leap years. I don't know. So, very interesting. But the main problem for Prince William Sound is that we have fewer strong year classes, and their magnitude is much lower. So Sitka still has a fishery. It had a strong year gap like we did, but they've had more recruitment going on than we have. But right now, in Prince William Sound, we do have a strong year class, the 2016 year class. So the figure that I'm showing you here is the same one that I've shown you before, where it's recruitment, the number of fish entering the spawning population on top. And then you can see that my pointer doesn't really work, but the last peak with a red circle on it, that's the 2016 year class. So that's the recruitment we're looking at. It's still a relatively low peak. But if you look at the second figure and go down to the 2016, that second figure is scaling the recruitment by the spawning biomass. Basically, the kid to parent ratio, how many kids survived to how many parents there were kind of. So we can see that there's a ton of recruitment in 2016 for Prince William Sound, despite there not being a lot of spawning going on. And I can, my next figure, I'll show you a picture of that. But, looking at the success of this 2016 year class kind of tells us, gives us some more information about recruitment in Prince William Sound. So here's just a map showing you the spawning that occurred in 2016. So there's 3 major areas. There might be a little bit in some other areas that we can barely see. As far as mild days of milt, I think it was an all-time low. And so nothing spectacular about this spawn event. The only thing that was interesting is that it was a leap year. And then Prince William Sound Science Center does aerial forage fish surveys. So fly over and you can tell which schools are age 1 herring. And in 2017, the data showed that there were a lot of age 1 herring schools out there. And just to give you an idea, I have a rolling video that shows year by year how many, it's the blue circles that you're looking for. But there's for 2017, when the 2016 year class was a year old, there were a lot of schools out there. So that indicated that, there wasn't a lot of spawning in 2016, but there were a lot of year one fish in 2017. So they survived. Herring are kind of like sea turtles, where they throw them out there and not many of them survive, But that year was something special about that year, where the conditions were just right that a lot of them did survive. And, just to point out, like the 2012 year class was also thought to be a strong year. It's a leap year again. And in 2013, the aerial age 1 surveys showed a lot of like large age 1 herring schools. So, okay, looking good. But when they were supposed to recruit into the population, they didn't show up. So just to put this in the context of their life cycle, like that first year of their life is a very high mortality period. But if they can make it past that, most likely they're going to be fine. The major things that cause mortality in those early stages is starvation and predation. So they have to eat, and they have to, hopefully there won't be predators in the water to just eat them, because a lot, for much of that stage, they're at the mercy of predation. But once they pass their first winter, then survival kind of goes up. And when we see that the herring live past year 1 and survive that high mortality period, but then they don't show up to recruit, or they die as adults, disease is our major hypothesis for the loss of a strong year class when they've already survived beyond the part that should be the hardest part to survive. We know that there's predation in whales and stuff, but disease can cause up to 90% mortality in some cases. It can really decimate a strong year class. Whereas, as far as whale observations in Prince William Sound, it's kind of variable, hard to track. So, yeah. And just, going back to the 2016 year class, despite this strong year class, it's very exciting. We're still below the fishery, opener limit. But this may change if we continue to see strong year classes in like building. Maybe it won't. I don't know. But we do have hope that the 2020 year class will be a strong year class. We're seeing similar patterns to what we saw with 2016. There's a figure that the red is the spawn areas for 2020. So seeing more coverage of areas for 2020 than 2016, probably a good thing. Eggs in more baskets, that's good. And then in 2021, during the aerial forage fish surveys, there's a lot of schools out there. So they're there. Whether or not they recruit next year is the question. So cross your fingers and toes and pray to your gods. And and hopefully at some point we surpass the fishery threshold within our lifetimes. And then here's just some spawning pictures if you can see them. One thing I didn't mention is that in 2021 and 2022, Fish and Game, they do survey Kayak Island, which is an island about 70, 80 miles southeast of the entrance to Prince William Sound, Pigeon Brook. And we have seen unprecedented spawn events there. It could be that it always happens and the planes just started in the air at the time of that really good spawn going off, but we've caught it the last 2 years. It's really impressive. There's big mile-long school, like big, large schools. And then this year we saw spawning at Glacier Island, which hasn't been observed since 1992. So that's exciting. A lot of good spawn going on this year. So hope for herring. And at this point, I'll take any questions. Go for it.
So it looks like when you're showing the map of the spawning grounds, it's mostly in eastern Prince William Sound. So when you showed the actual distribution of the population, it looked pretty heavy in the west as well. Is there a reason you don't spawn on that side?
That's like almost a pre and a post collapse kind of phenomenon. That prior to the collapse, there was spawning even in like the nooks and crannies of Night Island, and like Montague Island was a big spot, and like Naked Island was a big spot, and then northwest was good. But since then, it's almost completely contracted to a few spots in eastern Prince William Sound. So the fact that we're seeing spawning at Glacier Bay or Great Glacier Island and some other new spots, more at Montague Island, that's all very encouraging. That they're, is not a great indicator that they would contract spawning to just a few spots. And then alternatively, there is the thought that maybe they're going to Kayak Island, but we don't have a way to tell.
Okay, I'll do this. Most recent spawning is seen in eastern Prince William Sound, while all the salmon hatcheries and remote release sites are in western Prince William Sound. Adding that every increase in numbers of salmon fry released from hatcheries every year would be nice. It would be nice to see over the herring graphs. Do you know what year Piswak's remote salmon hatchery fry release started at Port Chalmers on Montague Island, downstream from the traditional spawning grounds of northern Montague Island? Does that make sense?
Yeah, yeah.
Okay.
I don't know the specifics of like when and where the the hatchery operations and where the fry end up. There is a project starting this summer that's supposed to look at interactions between salmon fry, herring, young herring, old herring, and predation between both species. So we're kind of like a colleague at the Science Center is going to be looking directly at that question. But I know that the increase in hatchery fry probably has a very increase as the herring went down. Whether that's coincidence, I mean, it's something that it's relatively untalked about, I think, for a reason. But it's there's no data to back up that the hatchery fry or what caused anything. And did I miss a part of that question? I feel like I missed a bit. But yeah, it's a really good point.
Any other questions? All right, thanks, Alysha. Excellent.